Okay then folks, today we're going to have a look at coloured light and the way in which coloured light works, how we see colour, and learn about how we generate the coloured light as well. So first of all, you need to know all the colours of the rainbow. There is a handy little way of remembering this, and that is remembering the phrase Roy G. Biv. And this stands for all of the colours of the rainbow that you need to know. You've got red, orange, yellow, green, blue, indigo, violet. There's a couple of different ways of remembering that order as well, but Roy G. Biv is the way that I remembered it. It's short and sweet and simple. So, first of all is knowing about how we split up white light into coloured light, because white light, which is coming in here, and is a little bit odd because it's obviously coloured yellow. If I coloured it white, you wouldn't be able to see it. And the way we split the light up is by bending it. So this is the same way that rainbows appear in the sky when it's raining. It's because the light is being dispersed and being split up. So when we shine light through a prism, it undergoes refraction. Remember, this is when the light is bending. We did this last lesson where it goes from different densities. So here we're going from somewhere less dense to more dense. So the light is bending here, and then it bends a second time here as it comes out. On this bit here, just a bit of a recap. Here we are bending towards the normal, and on this bit here we are bending away from the normal each time. So we've got a bit of double bending. But some of those lights are able to be bent a bit more than others. So we end up with the red being diffracted, not quite as much as the violet down at the other end. So there's a quick task here for you to do. So this is a good opportunity here for you to pause the video, have a chance to get this diagram down and answer these 5 questions. So now that you've done that, we'll just answer those. So obviously draw and labelled and coloured in the diagram. The 7 colours, you've got your red, orange, yellow, green, blue, indigo, violet. The one that's being bent the most is the violet, and red is being bent or refracted the least. And a mnemonic, that could be anything that you've come up with to remember those orders of Roy G. Biv, whichever way it makes for you. So another task for you to do now. So I'm going to give you an opportunity again to pause the video and for you to fill in the blanks here. Okay, so now that you've filled in the blanks, let's have a look at the answers. So have a chance here to again pause the video and read through and make sure that you have got the words in the correct spaces. Okay, moving on. So I said before that coloured light comes together and makes up white light. So there are 3 primary colours of light, and that is the red, the blue and the green. So your red here, can't write red on red, red here, your blue here and your green here. When all 3 of those colours come together, we get white light. Okay. When you mix those colours together as well, we get these other in-between colours. So we've got yellow here, we've got cyan here, and we've got magenta here. And these are what we see when we mix those primary colours together. So obviously red and green come together to make yellow, green and blue come together to make cyan, red and blue come together to make magenta. But shine all of those lights together and you will see white light. So it's just making sure that you remember those mixes. It's really important that you can name the colours that make up those 3 colours at the end there, yellow, magenta and cyan. Okay, so how do we see different colours then? We see colour of objects because objects reflect certain colours and absorb other colours. So for example, if I am looking at an object that is green, then that is because that object reflects the colour green, but it absorbs the other colours of light. So I only see the green light. For example, grass. So white light would be coming down from the sun here. It would hit the grass and it would reflect only the green light coming off. All of the other colours would be absorbed, and it would be the green light that shines into our eye, and we see the grass as being green. If an object looks white, then of course it's reflecting all of the colours of the spectrum, because all of those colours together make white light. Whereas if the object is black, that's because it's not reflecting any light, it's absorbing all the light, and what our eye is seeing is an absence of light. It's not registering anything, so therefore it just looks black. So another little short bit here. Can you put the words reflect and absorb in the right spots here? So objects looked coloured because they reflect some colours of the spectrum and absorb other colours of the spectrum. Actually, it wouldn't matter which way around you get the words there, but from now on it would do. So the grass looks green because it only reflects green light and it absorbs all of the other colours of the spectrum. Objects look white because they reflect all of the colours of the spectrum. Objects look black because they absorb all of the colours of the spectrum. So let's do a quick true or false quiz. So there are 8 colours in the spectrum. Is that true or false? It is of course false. Roy G. Biv, it's 7. A little bit of a recap from a few lessons ago. The angle of incidence is always equal to the angle of reflection. True or false? It is of course true. Refraction means when white light splits. True or false? Well, kind of true. Refraction is where the light is bending, and of course if you keep refracting it, it will then cause it to split up. Refraction means when light bends. This is true. The grass looks green because it only reflects green light. This is true. Light travels in wiggly lines. That of course is false. Light travels in straight lines. That is of course true. And on the Skittles advert it says taste the rainbow. Everyone likes a fun question. That one's true. Okay, so we can make coloured light by adding filters in front of lights. So at theatres, for example, they can change the colours of the lights by popping filters in front of it. And we're going to look at how this works and what effect this might have on colours that we're seeing as well. So filters only allow particular light to pass through them, and they absorb the other colours as well. Okay, so for example, if we're looking at a red filter, it's going to allow red light to pass through it, but it's going to be absorbing all of the other colours. So if we look at number 1 here, this is a red filter, so the white light is coming in. White light's made up of all the colours, but as the filter's red, only the red light is allowed to pass through and it absorbs the other colours. On the next one, the blue filter, this time only the blue light can pass through and it absorbs the other colours. Finally, this is when we have 2 filters next to each other, so we have to think about each of them in turn. So we've already looked at the blue filter. First of all, we have to consider this first. So the white light passes through here. The filter is blue, So it's only going to let the blue light through. So this is the explanation that we had here. That blue light hits then a second filter, and this filter is now red. But red filters can only let red light through. There is no red light hitting it, there is blue light. So it will absorb the blue light, meaning that there is no light coming through the other side. So our eye would not be able to see anything at all because no light would now be reaching the eye. So let's look at this exam question. I'm going to give you a few minutes to answer this. So pause the video, look at the question and think about what the answer would be. So, no light would reach the screen. Explain why. Well, we've got white light coming in here. White light's made up of all the colours of the light. It's hitting a red filter. So the only colour that's going to be allowed to pass through this filter is red light. All other colours would be absorbed. So we've then got, after we've gone through the red filter, we've now got a green filter. Green filter is only going to let what colour light through? Green, of course. So if there is red hitting the green filter, red cannot pass through a green filter. So now the red light will be absorbed. Can't spell. Red light absorbed by the green filter. So no light is going to reach the screen. Question number 2 is what would happen if you cut a circular hole in the green filter? So if we go back here and we now make a hole here in this filter, then that red light will be able to pass through that hole and we would see a circle of red light the same size as this circle over here, because the red light would now be able to pass through that hole because there's nothing stopping it from going through. So today's question to check your understanding that I would like to send back to me is this question here. So there's a lady here in a red dress. She is going to go into a club. When she goes into the club, her dress now looks black. Outside the club, we have got white light, natural light. Inside here, we have got lights that have got a blue filter on them. So there is just blue light in here. I want you to think about why the dress appears to look black when she is in the nightclub. You can type this out on a Word document and upload it and send it to me on Teams, or if you do decide to write it in your book, you'll need to scan it in or take a picture and attach that to your work in Teams instead. If you need any further help, I've uploaded the PowerPoint so you can work through it on your own, and there are some further links here that you can look at. The BBC Bite Size website has got some nice straightforward notes, and there's also one of the cheesy scientific eye YouTube video links there that goes through in a bit more lengthy detail about how we see the colours of light.